This is Examples in Music for Module 53. Let's listen to this string quartet by Stravinsky, and then we'll do some analysis. Objective 53.1 says correctly label sets related by transposition with a TX number and correctly label sets related by inversion with an index number. For this example, we're going to look at this segment of the piece. I've zoomed in, and we're going to look at this chord labeled A and this chord labeled B. The pitches involved are G sharp, F, A, D, which turn into the integers 8, 5, 9, 2. To put those integers in normal order, they would result in 2, 5, 8, 9. The pitches of chord B are A, G flat, B, E flat, or the integers 9, 6, T, 3. Putting those in normal order, we have 3, 6, 9, T. To determine if these sets are related by transposition, we're going to subtract one from the other. Let's subtract set B from set A. 2 minus 3 is negative 1, 5 minus 6 is negative 1, 8 minus 9 is negative 1, and 9 minus t is negative 1. Mod 12 arithmetic turns all of these integers into e. Since the resulting number is the same for all, these two sets are related by transposition. We can express this relationship through a formula that looks like this. A equals TXB, where A stands for set A, B stands for set B, T stands for transposition, and X stands for the number of half steps of the transposition. So we're going to replace the X with an integer, in this case the integer E. A equals TEB. It is sometimes helpful to read the label backwards for clarity, meaning if you take set B and transpose it by 11 half steps, the result is set A. And you can see that from the piece as well. If you take 3 and transpose up 11 half steps, you get the D. T transposed up 11 half steps gets you 9. 6 transposed up 11 half steps gets you 5. And 9 transposed up 11 half steps gets you 8. Let's say you wanted to express the same relationship, but instead of saying what A equals, you want to say what set B equals. Then, instead of subtracting set B from set A, you would need to subtract set A from set B. 3 minus 2 is 1, 6 minus 5 is 1, 9 minus 8 is 1, T minus 9 is 1. These sets are still related by transposition, and the resulting number is the inverse of the other one. 1 is the inverse of E. Expressing this in the formula, in terms of set B, we say set B equals T1A. Or reading it backwards, if you started with set A and you added the number 1 to each integer, the result would be the pitch classes of set B. Now let's compare a different chord. We're going to use the same set A that we had before, but now we'll look at this chord, which we'll label set C. The pitches involved are B, A flat, D, and G. E, 8, 2, 7. And the normal order of set C would be 7, 8, E, 2. If we subtract set C from set A, mod 12 would say 2 minus 7 equals 7, 5 minus 8 is 9, 8 minus E is 9, and 9 minus 2 is 7. Since these are not all the same resulting number, these two sets are not related by transposition, but they might be related by inversion. To find this, we need to reverse the order of one of them. We can reverse either one. We're going to reverse set C. We have set A as normal, and our reversed set C is 2E, 8, 7. Once you have your original set and your reverse set, you're now going to add these together. 2 plus 2 is 4. 5 plus E is 16. Mod 12 equals 4. 8 and 8 are 16, mod 12 equals 4. 9 and 7 are 16, mod 12 equals 4. Because these are all the same number, our original two sets are related by inversion, and they have what's called an index number of 4. The index number represents the number of half steps of transposition involved along with the inversion. We can express this relationship with a formula as well, and that formula is A equals T4IC. A is referring to set A, C is referring to set C, I means that the two sets are related by inversion, and T4 means there's a transposition index number of 4 half steps. Let's look closer at set A and set C to see how they are related by inversion with an index number. We said that set A 2, 5, 8, 9 and set C 7, 8, E2 are related by inversion. We discovered that because we reversed the order of one of them and then added them together, all calculations coming up with the same number, 4. We express this in this formula, A equals T4IC. Here is our original set A, 2, 5, 8, 9. Let's find the direct inversion of this using the rainbow method. The inversion of 9 is 3. The inversion of 8 is 4. The inversion of 5 is 7. The inversion of 2 is T. Each of the original numbers and their inverted number add up to 12. Now let's add our index number of 4 to each of these digits in the inversion. 4 plus 3 is 7. 4 plus 4 is 8. 7 plus 4 is E. And T plus 4 is 2 using mod 12 arithmetic. As you can see, by adding our index number to the direct inversion of set A, the result are the numbers in set C. Keep in mind, if you go through these steps to verify your work in this manner, make sure you do the inversion first and then the transposition. If you do the transposition first, followed by the inversion, you will not get the correct result. Also, in this context, whenever we speak of transposition, in this case the number 4, we're always talking about adding a positive number to the other integers. In effect, a transposition up rather than a transposition down.